Hello, welcome to the video notes for lesson 1-6, problem solving with real numbers. This is the last lesson in this topic and it begins on page 33 in your notes. Let's take a look at the learning targets for this lesson. I can use what I have learned about rational and irrational numbers to solve problems. And really that's the big idea here. That's why we're doing all this, because we want to be able to solve problems. And right away on page 33 we have a word problem that we're going to be able to solve together. So I'm going to slide this up so we can see the whole thing and have plenty of workspace, because we're going to need every bit of it. Alright, so right away before we get started, I noticed that we're dealing with a word problem, so I know that I'm going to need a word problem strategy like Bucks so that I can keep everything organized. So I'm going to write down Bucks on the side, and there we go. So let's read the problem. A pizza store offers 3 pizza specials. So there's 3 specials. Special number 1 is a square pizza with side lengths of 13.7 inches. That costs $20. Special 2 is a round pizza with a diameter of 13 inches. That costs $22. Special 3 is a rectangular pizza with side length of square root of 128 inches and the width, which is the square root of 157 inches. That costs $25. Which special is the best deal? Okay, so first off, I know that I am going to need, I have 3 different specials, so I might as well split my workspace up into 3 parts. And maybe that'll work. Let's scooch this over a little bit. Let's see here. That should do. Alright. So, the first one, special 1, is a square with a side length of 13.7 inches. Special 2 is a round pizza or a circle with a diameter of 13 inches. And special 3 is rectangular with, well, these interesting dimensions of the length and the width. So let's go with, we got special number 1, number 2, and number 3. Now, before we get going any further, let me put a star here, copy this down. We are going to find the area of each pizza. Of each pizza, then find the square inches per dollar. Inches squared per dollar. Now you might be saying, well, Mr. Decker, isn't that backwards? It is kind of backwards from what we're used to. We're used to finding the rate, the dollar per inch, but or the amount per inch. But I think when you see what we end up with, it'll make a lot more sense by finding out the number of inches per dollar that you spend. And we'll talk about it when we get to the end. Alright, so I'm going to draw a picture of a square, and it doesn't have to be perfect. And the side is 13.7. Then I've got a circle. That's a pretty decent one, with a diameter of 13 inches. And special 3 is going to be my rectangle. And this is square root of 128. And the square root of 157. Alright, so To find the area of a square, that's pretty simple. You square the sides, or multiply the sides together, length times width. When you do, you get 187.69 inches squared. So now I'm going to divide that answer, inches squared, divide it by $20, and when I'm done, I get about, I'm going to round it to the nearest hundredth, 9.38 inches squared per dollar. So you get a little over 9 inches of pizza for every dollar you spend. Okay? Very important. Number 2, area of a circle is A equals pi, r squared. So what we're going to do is we are going to square the radius. Well, they give us the diameter, not the radius. So the radius is half of this, which is 6.5 inches. So do 6.5 squared, and you get 42.25, and then multiply that by pi. And you get the area is, now remember, pi is an irrational number, so it goes on forever, 132.7322, well, let's just say it keeps on going. Leave that in your calculator. Now hit the divide button, and you're going to divide that by the price for special number 2, which is $22. So divide it by $22. And the answer is about 6.03 inches squared per dollar. Okay. Now the rectangle is going to be an interesting one because we've never dealt with this before. So when you're multiplying and you have square roots, you can actually just multiply the two numbers and then take the square root of the final answer. So when you multiply 157 times 128, you get 20,096. Now that is not a perfect square. So when you take the square root of 20,096, you get 141, and since it's not a perfect square, it's not a rational number, so it's going to keep on going forever. So we'll just write 141.7603 dot dot dot, leave it in your calculator, divide it by 25 because that's the price for that pizza, and when you do, you get about 5.67 inches squared per dollar. Alright, so which one is the better deal? Which is the best deal? Well, let's see. So since we're not worried about getting the better rate, if we did, we would have divided the other way. We would have divided the cost by the square inches. We're looking for getting more per dollar. So since the first one is giving us more square inches per dollar, that is the better deal. So final thing we're going to do at the bottom, you should still have plenty of room because there's a lot of space here. Special number 1 is the best deal. because it is more, all caps, so I'm yelling at you, square inches per dollar. You're getting more pizza for every buck you spend. Alright? Pretty heavy duty problem, so it's kind of a nice way to start this last lesson. Alright, I'm going to clear the screen, so pause it if you need to write more. And I'm going to flip to the next page, page 34. Now, we're not going to do all these, we'll do just a couple together, but what I want you to do is finish this on your own because the answers are at the bottom. So let's take a look at the first one. The area of a square dinner plate is 26 centimeters squared. What is the length of one side of the dinner plate to the nearest tenth of, should not be an inch, should be centimeter, because that's our units. So I always love to draw a picture when they give us a description of a shape like a square, which is easy to draw a picture of. Now we want one side length. Now since it's a square, the formula for area of a square is area equals side squared. Length times width, but the length and the width are the same, so we can call them S, and S times S is S squared. So how do you find, so now I'm going to plug in my area, 26. How do you find S? We don't want S squared, we want S. Well, you take the, that's right, square root. Now, S equals, this is not a perfect square, so actually, I'm going to do squiggly equal sign, because it's going to be an approximate answer. And when I look at what is on my calculator, I see 5.1 something. So I round it to 5.1 centimeters, and there's my answer. Now it's a word problem, so let's answer this in a sentence. The length of one side of the dinner plate is about 5.1 centimeters. Now, the next one, Miss Kula wants to buy a new sofa that is the square root of 55 feet long. She wants to place it along a wall that is 7 feet wide. Will the sofa fit along the wall? Justify your answer. Alright, so the sofa is 55, the square root of 55 feet. That is in between the square root of 49 and the square root of 64. That is my hint to help you with answering this one. So go ahead and do that one on your own and number 3 on your own. I am going to help you with the last one because the last one's a little tricky. The last one says, is the square root of x plus y plus z rational or irrational? Now, if we were doing the square root of x plus the square root of y plus the square root of z, we would not be able to answer this problem because you can't add square roots like you add normal numbers. You actually have to add them like you are adding like terms. So, but since it's just one square root symbol, or radical symbol as it's called, we can actually add these numbers together. And when you do, you get the square root of 64. Now, we know that the square root of 4 is 8, or excuse me, square root of 64 is 8. I want you to finish this problem by doing the explain. See what kind of explanation you come up with. Alright? So that's it for this video. Wasn't terribly long, although I'm sure some of you might disagree. If you had any trouble with any of these problems, certainly go back and rewatch the video or come and see me for help. Good luck, and we will see you in math.